students, today we can see some problems and results relating how we can find the analytic function. So here you can see Milne-Thomson method. One of the method is Milne-Thomson method. So if a real part is given, then we can find f is equal to integral phi 1 x z comma 0 minus I phi 2 is z comma 0 dz plus c, where phi 1 equal to dou u by dou x and phi 2 equal to dou u by dou y. If imaginary part is given, then we can find the analytic function f is equal to integral psi 1 plus I psi 2 at the point z comma 0, where psi 1 equal to dou b by dou y and psi 2 is equal to dou b by dou x. So if real part is given, then f of z is equal to integral phi 1 plus I phi 2 into minus I phi 2 dz plus c, and if imaginary part is given, is integral psi 1 plus I psi 2 into dz plus c. The second method is we can use CR equation. That is, if a real part is given on the question, then dv equal to dou b by dou x. This is the normal chain method. Dou b by dou x into dx plus dou b by dou y into dy. So which is equal to, this will be converted by using Cauchy-Riemann equation. So we know that Cauchy-Riemann ux is equal to vy and uy is equal to minus vx. So using that, vx which is equal to minus uy and vy is equal to ux. Okay, so integrating this dv, we will get v. Okay, so u is already given in the question and v we found. Using that, we can find easily the analytic function f is equal to u plus iv. Substitute the values, you will get it. Similarly, if v is given in the question, that is imaginary part is given in the question, then we have to use du. Du is equal to dou u by dou x dx plus dou u by dou y dy. So again, we have to use the Cauchy-Riemann equation because we know only the imaginary part. So we have to convert in terms of v. We have to convert in terms of v by using the Cauchy-Riemann equation. Again, here also we can integrate du so that you will get u. Also given at the question b, so that f is equal to u plus iv. That form give the analytic function. So there are two methods to find the analytic function. So here you can see the next example. For given ux comma y, x cube plus 3xy square plus 3x square minus 3y square plus 1 whose analytic function. So here I am using the first method, that is Cauchy-Riemann equation. Cauchy-Riemann equation we can use and find the method. So see here, we can use the first method, that is Milne-Thomson method. Milne-Thomson method. Or we can use the second method, that is Cauchy-Riemann equation. The Cauchy-Riemann equation is somewhat a wider method while comparing the Milne-Thomson method. So here real part is given, the formula is f is equal to integral phi 1 z comma 0 minus I phi 2 z comma 0 into dz plus constant c, where phi 1 is equal to dou u by dou x. So from this, dou u by dou x is 3x square minus 3y square plus 6x. Again phi 2, that is equal to dou u by dou y, which is equal to minus 6xy minus 6y, right? And we can see both also defined at the point z comma 0. So at z comma 0, this phi 1 value becomes 3z square plus 6z at z comma 0. Again here phi 2 value is, y is here 0, 0. So it is totally 0. Now we can substitute this in equation number 1. So equation 1 gives f of z is equal to integral phi 1 value is 3z square plus 6z minus I into phi 2 is 0 into dz plus constant c. So that we will get, that is equal to 3z cube divided by 3 plus 6z square divided by 2 plus constant c. So it is equal to z cube plus 3z square plus constant c. So which gives option is B is the right one. So we can use the second one, Cauchy-Riemann, it gives somewhat wider one while comparing this, some elongated one while comparing the first method. So better Milne-Thomson method. Now we can see the results. If Fz is analytic, then Fz satisfies CR equation. So if we need analytic, then it satisfies CR equation. Then Fz is analytic means U and B are harmonic function. Similarly, we have the result if Fz is analytic, then U and B are the continuous function. That also we have. So analytic means satisfies CR equation, U and V are harmonic function, and U and V are continuous function. Now we can see the third result. If V is the harmonic conjugate of U, then Fz is analytic. If this is also satisfied, that is a V is the harmonic conjugate of U, then also we can say that Fz is analytic. Now the fourth one, if a function Fz is analytic, then we can say it is differentiable at the particular point and differentiable at infinitely many points, and that it is continuous, because we know that differentiable implies continuous. Using that, we get the third one. So remember, analytic implies differentiable. Differentiable at the particular point, infinitely, and continuous also. Now the fifth one, the function modulus z square is. So out of this four options, which are right? So Fz is equal to modulus z bar the whole square. So modulus z bar the whole square, we know that which is equal to modulus x minus iy the whole square, which is equal to x square minus y square, right? Root of x square plus iy the whole square. So from that, x square minus y square. From this you can write u of x comma y is equal to x square minus y square, and here no imaginary part, so that v of x comma y is equal to 0. So for finding the differentiability, we can check the Cauchy-Riemann equation. So Cauchy-Riemann, ux is equal to vy and uy is equal to minus vx. So here ux, u is here x square minus y square. So ux is equal to 2x. Similarly, uy is equal to minus 2y. And vx is equal to 0. Again, vy is equal to 0. So comparing this Cauchy-Riemann equation, you will get 2x is equal to 0 also. Then uy equal to minus vx, that is minus 2y equal to 0 gives 2y equal to 0. This gives x is equal to 0 and y equal to 0. The question you can see differentiable at z equal to 0. That means x comma y is equal to 0 comma 0. So x and y are 0. So while substituting here, if you substitute the value, x value is equal to 0 and y value is equal to 0. So that you will get 0 and 0 is equal to 0. So it satisfies CR equation. So we can say that it is differentiable at, here the point is given, z equal to 0. But it is not analytic. The analytic, the condition, it satisfies CR equation. But CR equation, here you can see the option A, it is analytic at the particular point is not given. So here it is not satisfied. X equal to 0, y equal to 0. If you put x and y as 0, then the inequality will be okay. So that it satisfies only the differentiability at z equal to 0, but it is not satisfied the CR equation at the difference point. So it is not analytic. So it is not analytic. Okay. So differentiable is right, not analytic is right, and differentiable implies continuity. So option D is also right. Thank you.